Alright guys, so this section 3.4 is on reasoning in geometry. Our goal here, or our objective, is to understand mathematical proofs. We're going to be learning to construct a proof. So we'll be using theorems of parallel lines cut by a transversal, as well as properties of parallelograms a little bit. So over the past unit, we have been talking about and learning about when I cut a set of parallel lines with a transversal, the types of angle pairs that are created, and we've been talking about what relationship those angle pairs have. So these are actually theorems and postulates in mathematics that are taken to be true, and we can use them as I guess reasoning of why we can say certain things are true about different angles and all that stuff. So we're going to learn how to write a proof. We're going to use some of these theorems. So these are the more officially written theorems that we've learned. So we've learned if two parallel lines are cut by a transversal, then corresponding angles are congruent. The converse of this postulate is also true, meaning that so like in the first one, if I know the lines are parallel, then I know the angles are congruent. The converse says if I know the angles are congruent, then I know the lines are parallel. So these are true in both directions. So if I know one thing, I can conclude the other. If I know the lines are parallel, I can conclude the angles are congruent. Or if I know the angles are congruent, then I can conclude that the lines are parallel. So that's why I have here like corresponding angles postulate and the converse of the corresponding angle postulate. I have both because they're both true. So that's true for all of these theorems. So just kind of keep that in mind. We know that alternate interior angles are congruent if the lines are parallel. We know that alternate exterior angles are congruent, and we know that consecutive interior angles, sometimes called same-side interior angles, are supplementary, right, if those lines are parallel. So those are some of the theorems we're going to be using to back up some of our claims throughout these proofs. Some of the other things that we will use is that vertical angles are congruent, that linear pairs are supplementary, and sometimes properties of parallelograms like opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary. So basically all of these all of these theorems and these definitions we can use as we write the proofs as evidence for things being true, okay? So some of the definitions and rules that we might use is, one of them is called the substitution rule. So basically the substitution rule, you've used it a lot. If I know that x equals 5 and I know that y equals 2x minus 5, then I know that y is equal to 5. And the reason is because I can substitute this 5 in for this x because I know x and 5 are equal. So that gives me 2 times 5, which is 10, and then 10 minus 5 is 5. And that's why I know y is equal to 5. So the substitution rule is just what it sounds like. If I know two things are equal, then I can substitute one in for the other. So that is one of the rules that we will be using to back up some of our claims as we construct these proofs. Here's a couple of other properties that we will use. One of them is called the reflexive property of congruence, and this one is very obvious, right? If I have figure A, it's going to be congruent to figure A. It's basically just saying things are congruent to themselves, okay? So actually in mathematics, proofs are extremely precise. And I am actually not going to make you be so precise that you have to say that EF is congruent to itself, okay? So the main one that I want you to look at here is the transitive property of congruence. Really quickly, the symmetric property of congruence basically just says that it doesn't matter which order I write angle 1 and angle 2 in, they're still going to be congruent to each other. So if 1 is congruent to 2, then 2 is congruent to 1. Sorry, I skipped ahead on accident. So that's the symmetric property. But this transitive property is one that we will probably use most often. So if you're going to write one of them down in your notes, write this one down. The transitive property of congruence says, here's an example, if line segment PQ is congruent to line segment RS, and line segment RS is congruent to line segment TU, then I know that line segment PQ has to be congruent to TU, right? So if this line is equal to this one and this one is equal to the next one, well then the first one has to be congruent to the last one. So that one is one that we'll use. It's called the transitive property. These two I'm just taking as obvious enough that we're not going to bother writing down those reasons, okay? Although they are, just if you were being really precise, you would want to use those, okay? A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So we're going to be basically given some given information. We're going to make a series of arguments and using logic, definitions, properties, theorems, and we're going to prove that the statement is true, okay? So that's our goal. So a very important part of writing a proof is that we have to give a justification to every claim we make. Okay, if I'm going to say that angle 1 is congruent to angle 3, I have to be able to tell you why. I have to be able to give you a justification for that. And that is usually either a theorem or a definition, or it can be something we've previously proved, or something that's been previously proved in mathematics and is just taken to be true, like the transitive property that we just talked about, okay? In this way we show that every step is valid and we go from one thing to the next in a very logical way, and we show that things are true, okay? So here's our first example that we're going to go through. So the given information here is that the line L is parallel to the line M. So if I'm looking at my little diagram here, this line here is parallel to this one. These are parallel lines, which tells me a lot about some of these angles and their relationships, right? It tells me alternate interiors are congruent. It tells me same side interiors are supplementary, and et cetera, et cetera, et cetera. This one is telling me I have this little extra angle over here, angle 4. This is telling me that angle 2, so this angle, is congruent to angle 4. So that's given, okay? It's given the lines are parallel, and it's given that angles 2 and 4 are congruent. So now what it's asking me to prove is it's asking me to prove that angle 3, which is right here, is congruent to angle 4, okay? So looking at that, as we kind of know that these are parallel lines and we know that these are alternate interior angles, we know that 2 and 3 are equal, right? And if 2 and 3 are equal and 2 and 4 are equal, then we know that 3 must equal 4. So we can kind of look at that and we can see that that's true. But in order to write like a formal proof for this, we have to be really precise and careful as we go forward. So the given information, we can just take that to be true because they told us that's what is true. But we have to prove the second part. We have to prove that 4 is congruent to 3. So this is how we're going to do it. We're going to do something, we're going to write something called a 2-column proof. And this is just a way to keep really organized and make sure that every claim that we make is backed up with a justification. So on this side, I'm going to be making statements or claims. And on this side, I'm going to be giving the reasons for those statements or claims, or the justification for those claims that I make. So the first line on your statements of your 2-column proof will always be the given information. So L is parallel to M, and angle 2 is congruent to angle 4. Okay, that is always going to be your first statement, and that's the given statement. So the reason that I can say that or make that claim is because that was our given information. Okay, now I know that 2 and 3 are congruent as well, and so I'm going to make the claim that angle 2 is congruent. Sorry, my pen is weird. But angle 2 is congruent to angle 3. So that's going to be my second claim. But I have to be able to back that claim up with a reason, right? And the reason is because angle 2 and angle 3 are alternate interior angles. So the claim, or the justification for my claim actually, is going to be the alternate interior angle theorem. Okay, so I just wrote this little symbol for angle, but the alternate interior angle theorem is the reason that I can claim 2 and 3 are congruent, because the lines are parallel, right? So that's the justification. Now I want to show that 4 is congruent to 3. And because I know that 2 is congruent to 4, and 2 is also congruent to 3, I've already claimed both of those, right? Now I'm going to claim that angle 4 is congruent to angle 3. And I can claim that because if they're both congruent to angle 2, they have to be congruent to one another, right? So this last one, if angle 2 is congruent to angle 4, and angle 2 is also congruent to angle 3, so I can say angle 4 is congruent to angle 3. That was that transitive property, right, of congruence. So I'm just going to say here it's the transitive property. Okay. I could technically say it's by substitution as well, because I'm substituting angle 4 here for the angle 2, because angle 2 and 4 are congruent, so I can substitute this angle 2 with angle 4. So another option for the reason here could be by substitution. But just make sure that each claim you make has a reason or a justification for why it's true. Okay? So let's go ahead and try another one. Let's see if we can. Okay. So on this one we have 3 lines, J and K and L. My given information is that J is parallel to K, so this line is parallel to this line. I have a fly attacking me. And then I'm also given that K is parallel to L, so those are all given information. I want to prove that angle 1, so this angle right here, is congruent to angle 3, so that one. Okay. So again, the first thing I want to do is make statements or claims, and then I want to back them up by giving reasons for those claims or justifications for them. So the first claim I always make is the given statement. So J is parallel to K and K is parallel to L, and the reason I can make that claim is because that was given information. Okay, so now it looks to me like I need to know that J and L are parallel so that I can claim these are corresponding angles. Because 1 and 3 are corresponding angles if J is parallel to L. And it seems kind of obvious to us that J is parallel to L, but again, we have to be pretty precise and we have to say the reason we can claim that. So my claim is going to be that J is parallel to L. And the reason that I can say J is parallel to L, again, is because of that transitive property. Because the transitive property says if 2 things are equal or 2 things are parallel, and then I find that one of those is parallel or equal to something else, then I can say that the first is parallel to the last. So the transitive property is the reason I can say that J and L are parallel. And now that I know that those are parallel, now I can make the claim that angle 1 and angle 3 are congruent. So angle 1 is congruent to angle 3, and I can say that that's true because of the corresponding angle postulate. Okay, so once I have made the claim of the thing I was trying to prove, right? Once I've made that claim, I don't need to go any further, as long as I have a reason to back up every claim as I went along, and that last one. Okay. All right, so let's try one more. All right, so on this one, it's telling me to complete the proof that the measure of angle WXZ plus the measure of angle SUT equals 180, so that these 2 angles are supplementary, right? So let's mark which angles those are so that we can easily see them. So WXZ, that would be this angle right here. SUT, that would be this angle here. And I'm going to mark this one with 2 lines because those are obviously not congruent, right? One's much bigger than the other. If I add these angles together, I should get 180 degrees. Now this is not one of our angle pairs, right? These are on the same side of the transversal and on the outside. So this is not one of our theorems. So we need to relate some of these angles to other angles so that we can get there. So there is no given information up here in my heading, but if I look at this diagram, I do see a bit of given information, and that's because of these little red arrows right here. Remember, those arrows tell me that this line VT is parallel to this line YW. So when I make my proof here, my first statement is going to be the given information, and that is that VT, this little line VT, is parallel to YW. Okay, and I'm putting arrows on the ends here because these are lines that keep going in both directions. So I know VT and YW are parallel. The reason I can say that is because that's given based on the diagram and the notation on the diagram. So now I can use things that I know about the angle pairs in parallel lines to get there. So one of the first things I'm going to do is try to relate these to one of the angle pairs that we do know something about. So let's say, for example, this angle right here, SUV. I know that SUV is congruent to our WXZ, so angle SUV is congruent to angle WXZ. Okay, I know those two angles are congruent, and the reason that I know they're congruent is because I know the lines are parallel, and these are alternate exterior angles. So my reasoning here is going to be the alternate exterior angle theorem. I'm not sure if it's a theorem or a postulate, but I'm not too worried about that part of it. Alright, so now that I have the SUV is congruent to WXZ, I can also see that SUT and SUV are supplementary because they're a linear pair. So I'm going to go ahead and say angle SUT plus angle SUV equals 180, right? And I can say that because they are a linear pair. So that's my reasoning or my justification for saying this, that SUT plus SUV equals 180. So now, because I know SUV is congruent to WXZ, I can go ahead and substitute in for SUV. I can substitute WXZ. So angle SUT plus SUV, right? But I'm going to substitute in WXZ for SUV because they're equal, equals 180. So my reason is because of substitution. Okay, so SUT plus WXZ equals 180. That's what I was trying to prove, right? It's written in a different order, so that's where I could use that property where it said that if I change the order, that it would still be the same. But I'm not going to be that much of a stickler on this. As long as I can tell that you have proven what it was asked to prove, then you should be good. So go ahead and give those a try. If you have questions, please email me. And good luck on this, guys. See you.